Hey math kids, today we're going to talk about rational functions. If we have rational functions in this form, we have a horizontal asymptote at y equals 0. Okay, we're going to look at this question over here. It says find the asymptotes of the function. So we know that there's a horizontal asymptote at y equals 0 because it meets this form. Now for vertical asymptotes, we need to know where the zeros are of the bottom. So if we factor this, we can see that 1 minus that, so it's going to be x plus 1, x minus 4. And so that's going to be negative 1 and positive 4 for the roots, or the zeros, and that's going to be our vertical asymptotes at x equals negative 1 and 4. It says find the axis intercepts. So to find the y-intercept, we plug in 0 for all the x's, and to find the x-intercept, we just find the roots, or the 0 of the top. So x-intercept is pretty straightforward. We just say 2x minus 6 equals 0. Add 6, divide by 2, so x equals 3. Now for y-intercept, we plug in a bunch of zeros. So 0 here gives us negative 6 on top, 0, 0, negative 4 on bottom. So that's going to be 3 halves. Okay. And then part C says draw a sine diagram for the function. So sine diagram is based on whatever happens on the x-axis. And so we have negative 1, 3, and 4, our place of interest. These are vertical asymptotes though, so we need to show that on the diagram. We need to pick our values that are in between these other values. And what I'm going to do is I'm going to plug it into a version of the so that's the function factored form. Sometimes it's easier to do it that way. Okay, so if I plug in a negative 2 here, overall the top's going to be negative. If I plug in a negative 2 here, this is going to be negative. Plug in a negative here, negative. Negative times negative is positive. Positive times negative is negative. Okay, if I plug in a 0, I get a negative. Plug in a 0, I get a positive. Plug in a 0, I get a negative. Positive times negative gives me a negative. Negative divided by negative is positive. Plug in a 3.5, that's going to be positive. 3.5 is positive, 3.5 is still negative. Positive times negative is negative. Positive divided by negative is negative. And then if I do a 5 here, that's positive, 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 which is positive. Positive divided by positive is positive. So there's our sine diagram. And now it says, hence discuss the behavior of the function near the asymptotes. So near this asymptote, it's first below the x-axis, and then when it goes to the other side, it's going to be up here. So it's going to be kind of like a situation where it's like going down on this side, and then kind of coming up, kind of like this. It's going to be that kind of situation. And then on this asymptote, same idea. It's going down when it's on the left, but it's going up when it's on the right. Okay. And then E, sketch the function showing the features you have found. Alright. So we have negative 1, we have 3, and 4. So we have asymptote here, We also have the asymptote here. That's our horizontal asymptote. And so we're going to draw the function looking like that. We have a y-intercept at 3 halves. So y-intercept is right there. And we have an x-intercept at 3. And so the function's going to go kind of like this. And then this one's going to go kind of like that. Okay, that one's done. Now we're going to move on to another one. Okay. Now, for this one, it doesn't fit the same form. And so this is going to create an oblique asymptote, which means it's not horizontal or vertical. It's just like a slanted line. So we'll go through this example, and when we come to that, we'll figure it out. Okay, so the vertical asymptote, though, is the same thing. It's just whatever creates division by 0, and so x is equal to -2. Okay, we want to find the axis intercepts. So to find the y-intercept, we plug in 0 for everything. So 0, 0 gives us a -9, 0 over 2, and so -9 halves would be our y-intercept. Now for the x-intercept, we're going to have to set the top equal to 0 and solve. So we can just use the quadratic formula for that. So -3 plus or minus square root 3 squared minus 4ac all over 2a. That's 4. -18. -18 times 4, 72. Alright, and then we get 9. So that's going to be 81. Okay, so that's -3 plus or minus 9 over 4. -3 plus 9 is going to be 6. And -3 minus 9 is going to be -12. And so we're going to get 3 halves and -3. Okay. And then C, find the oblique asymptote. So what we do, this is new, we haven't done this before. To find the oblique asymptote, we do polynomial long division, and the oblique asymptote is going to be the piece that is not the remainder. So we're going to do x plus 2. So we have to do 2x squared plus 4x, change the signs, those cancel, that's x, -x, minus 9. We need to do -1, multiply it back, -x, -2, change the sign, and -7. Now we do have a remainder with this -7, but we don't care about it in this situation. So we just want our oblique, let's see, asymptote is 2x minus 1. Okay. Now it says draw a sine diagram for the function. So we only care what happens on the x-axis for our sine diagram. So we have -3, -2, and 3 halves. The -2 is an asymptote, so we want to show that. Then we pick our values. Okay. When we're going to just plug it in. So I'm going to plug it into the green one right here. I'm going to erase some of this though. We don't really need this. Okay. So if I plug in -4, it's going to be 16 times 2, so 32, -12, -9. Overall, that's definitely a positive number. Plug in a negative here, it's negative. Positive divided by negative is negative. If I plug in -2.5, what am I going to get? Overall, let's see, bottom will be negative, top will also be negative. Negative divided by negative is positive. And then you plug in 0, you get negative and positive, so that's negative. And then you plug in 2, that's going to be positive number. So let's see, plug in 2, that's 4 times 2 is 8. Plug in a 2 here, we get positive 6. Those added together are bigger than 9, so overall that's positive. And then divided by positive is positive. So that's our sine diagram. Discuss the behavior of the function near its asymptotes. Okay, so this asymptote, it's above the x-axis going up, and this one's below the x-axis, kind of going like that. And sketch the function. So let's get rid of the stuff we don't need. So we need the sine diagram, we don't really need that. Okay. So let's mark -2. We have a vertical asymptote. Okay, we also have an oblique asymptote. So we start at -1, then we go up to over 1. And so we have an oblique asymptote. Kind of looks like that. All right. Now, -3 is a root, and 3 halves, so 1, 2, and then right there is a root. And then we also have -9 halves as a y-intercept. So essentially, we're going to come up this way, kind of follow that asymptote. The asymptote continues down there, okay? And then this one, we kind of follow this and follow this asymptote. Alright, it's kind of tricky, but if you have additional help, if you need additional help, come to Math Lab. Until then, calculator.